So last time we solved number of islands. We counted separate patches of land on a grid, and to do it, we used a little trick. We flooded each island, sinking all its connected cells in one go. Remember that? Well, today, I'm going to show you the problem that trick was secretly built on. The pure original idea behind it. It is called flood fill. And here's the fun part. You already did the harder version, so this one is going to feel almost relaxing. But do not be fooled. It is still a very common interview question, and the idea behind it is everywhere. Let me start with something you have absolutely used before. Open any Paint app, MS Paint, Photoshop, anything. You know that little paint bucket tool? You click inside a shape and the whole region floods with a new color. You click inside one closed area and only that area changes. The color spreads until it hits a different color, like a boundary. That paint bucket is literally flood fill. You have been running this algorithm with your mouse for years without knowing its name, haven't you? So here's the problem properly. We are given a grid of colors, just numbers really. We are given a starting cell, the cell you clicked. And we are given a new color. Our job is to fill that starting cell and every cell connected to it that shares the same original color with the new color. We spread outward, up, down, left, right, as long as the neighbor has the same old color as where we started. The moment the color is different, that is a boundary, and we stop. Let me make it real. Imagine a grid where the middle is full of, say, color 1, and it is surrounded by color 0. You click in the middle on a 1 and you say, make it 2. So flood fill starts at that cell, turns it to 2 and then spreads to every touching cell that was also a 1, turning each of them to 2 as well. The surrounding zeros? Untouched. They are a different color, so they act as the wall. Now, does this feel familiar? It should. This is the exact same spreading we did in number of islands. Back then, we spread across connected land and sank it. Here, we spread across connected same colored cells and repaint them. Same engine, different paint. It is, once again, a graph problem in disguise. Each cell is a node, and two touching cells of the same color are connected by an edge. A region of one color is just a connected component. And we already know how to explore one of those, DFS or BFS. So here is the plan, and it is wonderfully short. We start at the clicked cell. We remember its original color. Then we run a traversal. Let us use DFS. From the starting cell, we look at its 4 neighbors. For each neighbor, we ask one question. Does this neighbor have the same original color? If yes, we recolor it and dive into its neighbors too. If no, different color, or off the edge of the grid, we stop. We just keep spreading and repainting until the whole same color region is filled. But there is one sneaky trap here. And this is the twist that catches people off guard in interviews. Listen carefully. What if the new color is the same as the old color? Say the region is already color 1 and someone asks you to fill it with color 1. Think about what happens. You recolor a cell from 1 to 1, no visible change. So when you visit its neighbor and check, is this still the old color? It is. So you visit it again. And it sends you back. And you go round and round forever. An infinite loop. So before we do anything, we add one tiny safety check. If the new color is already the same as the starting color, we simply do nothing and return. Problem solved. This one line is exactly the kind of edge case an interviewer is secretly checking whether you will notice. Now you will. Let me walk through it quickly. We click the center cell. It is color 1 and we want color 2. First we check, is new color same as old? No, 2 is not 1. Safe to proceed. We paint the center cell too. We look at its 4 neighbors. The ones that are color 1, we paint them too and dive in. The ones that are color 0, boundary, we stop. We keep spreading through all the connected ones, painting as we go, until the whole blob is color 2. Done. Clean. Now let us write it a recursive DFS in Java. And this time, watch it fill every single cell, one by one. Our main function reads the starting cell's color, does one safety check. If the new color already equals the old, just return, and then calls DFS on the clicked cell, 22. Inside DFS on 22. Boundary check passes, it is on the grid and it is a 1. So we paint it 2 and look down. The cell below 3-2 is also a 1, dive in. Now on 3-2, paint it 2 and again look down. 4-2 is a 1 as well, so down we go. On 4-2, paint it. Down is a wall. Up is already painted, but look right. 4-3 is fresh. Dive in. 4-3, paint it 2. Down is a wall, but up, 3-3 is a 1. Keep going. 3-3, paint it. Down is already done, but up leads to 2-3. Deeper we go. 2-3, paint it 2. Up, 1-3 is still a 1. So we keep going deeper. 1-3, paint it. Down, up and right are all blocked. But left, 1-2 is open. One more level down. 1-2, paint it 2. Now check all 4 neighbors. Every one is a wall or already filled. Dead end. So this call returns, and we back out to the previous cell. We land back on 2-3, which still has a direction left to try, right. 2-4 is a fresh one, so off we go again. 2-4, paint it and look down. 3-4 is open. Dive in. 3-4, paint it 2. All 4 neighbors blocked. Another dead end. Return and be back out again. All the way back to 3-2, its last untried direction is left. 3-1 is a 1, so we take it. 3-1, paint it, then up into 2-1, paint that too. And 2-1 has no fresh neighbors. That is the last cell. Now every call returns in turn, backing out all the way to the start. 12 cells, all painted. The whole region is one color. That is flood fill. Now I have shown you this in Java. If you prefer C++ or C, no problem. The logic is identical. A safety check, then a recursive DFS that repaints in 4 directions. Only the syntax changes. I will put both versions on the screen now, so you can follow along in your language of choice. A quick word on speed. We visit each cell of the region at most a small fixed number of times. So the time grows simply with the size of the grid, rows times columns in the worst case. Very efficient, just like before. And of course, we used DFS, but BFS solves this identically. Instead of recursion, you would push same color neighbors into a queue and repaint as you pop them. Same result, same idea. Pick the tool you like. Let us bring it all together. Flood fill is the pure paint bucket problem. Start at a cell and recolor every connected cell that shares its original color. It is a graph in disguise, exactly like number of islands, a connected component explored with DFS or BFS. The one trap to remember, if the new color equals the old color, do nothing, or you will loop forever. Get that, and you have got the whole problem. And just like that, you have solved another classic, and more importantly, you can now see the same flood fill pattern living inside different problems. That pattern recognition is the real skill. Number of islands, flood fill, different stories, same engine. Next time, we finally switch tools. We have been using DFS to spread and mark. But now, we will ask a different kind of question. Not what is connected, But what is the shortest way to get from here to there? That is where BFS truly shines, and where its hidden shortest path superpower finally takes center stage. So, see you there.